Hello and thanks for watching Best Maths Tutors. I'm continuing to go through the Edexcel higher tier paper from 2019, and this is paper 3. I'm going through all the questions on this paper, so if this is helpful to you, please hit the subscribe button at the bottom. So this is question 18, and what we've got to do is we've got to show that this these three brackets, 2x plus 1, x plus 3, and 3x plus 7, can be written in the form, as we've got here, ax cubed bx squared plus cx plus d. And what we've got to show really is that if we multiply these brackets out, then we will get something in this form. So what I could do to begin with is take the x plus 3 and the 3x plus 7 and multiply out those brackets, and then what I'm going to do is take the result of that and multiply by the 2x plus 1. So first of all, I'm just going to multiply the x plus 3 and the 3x plus 7. So there's a few ways of remembering how to do this. One of them, the one I use, is FOIL, which stands for first. That means you take the first terms, multiply them together. So that would be x times 3x would give us 3x squared. And then you do the outside, so O stands for outside. We do this x times the 7, and that'll give us 7x. Then we do the inside, and that's the 3 times the 3x, so that'll give us 9x. And then we do the last terms. So the last terms in each bracket is the 3 and the 7. So we do 3 times 7, which is 21. And the advantage of having a method like this is that we don't miss anything out. If we didn't have a systematic approach, it's easy to miss something. There are other ways of doing this. You might have seen the smiley face method. So it looks a little bit like a smiley face if you were to imagine having the eyebrows and the nose and the mouth. But I like the FOIL one as a way to remember it. So what we then get is a middle term there, which we can, excuse me, we add the 7x and the 9x together, and that gives us 16x. So we've now got 3x squared plus 16x plus 21. So that was the result of the x plus 3 and the 3x plus 7. And what I'm going to do is I'm now going to multiply that by the 2x plus 1. And what that would mean is that every term in this second bracket is going to be multiplied first of all by the 2x. That's what I would do first. I'd go through every term, multiply it by 2x, and then multiply by 1. So both these two terms in the first bracket have to multiply every term in the second bracket. So what we do 2x times the 3x squared. So we can multiply the number part together. So 2 times 3 will give us 6. And we can multiply the x parts together. So the x and the x squareds, that will give us x cubes, because what we've got is that's an x to the power 1. And we add the powers when we multiply things with powers. So we go x to the 3 for that, 1 plus 2 being the 3. Then we go 2x times the 16. So 2 times 16 is 32. X times the x will give us x squared. Then we have 2x times 21. So 2 times 21 is 42. And then x, there's no x to multiply there, so it just becomes 42x. And now we go through by the 1. So we've multiplied everything in the second bracket by 2x. Now we go through by 1 there. So we can say, well, 1 times 3x squared is just 3x squared. In fact, multiplying through by 1 will just give us the second bracket. But 1 times 16x is going to be 16x. And 1 times 21 is 21. And what we have to do next is tidy this up by collecting up like terms. Just like we did in the first part where we added the 7x and the 9x together to make 16x, we've got to look for things which are alike and add them together. So there's only one term with an x cubed in it, so that just stays as it is, 6x cubed. And then we can look at the next lowest power, which is the x squared. And so that would be 32x squared plus 3x squared. So we've got 35x squared. Now we can look at the x. So 42x's and 16x's. We just add the 42 and 16 to give us 58. 58x. And then that's plus 21. And we've actually done it because it says write it in the form ax cubed plus bx squared plus cx plus d, and a, b, c, and d are integers. But we can see in our case, and you don't need to write this little bit here, but we can see in our case that a is equal to 6, that's the number multiplying the x cubed. We can see that b is equal to 35, and b equals 35. We can see that c equals 58, and we can see that d is just 21. So we're now going to look at part B. So part B is an inequality, and what we're told is that 1 minus x all squared is, and that means less than, so that's less than 9 over 25. There's some alternatives to the inequality there. We could have that which would mean less than or equal, and that would be greater than, the other way around, should be more of that, there we go, greater than, and that would be greater than or equal to. So we've got here that the 1 minus x all squared is less than 9 over 25. So there's a couple of approaches to this. We could actually square out the bracket and we might get a quadratic then, a quadratic inequality which we'd need to solve. But probably the easiest thing to do here is to actually square root both sides, because we notice that if we square root the 9 there, we get 3, square root the 25, we get 5. So it's going to give us quite nice numbers. That's the method I'm going to choose. So if I square root the 1 over the x squared on the left hand side, and then that's going to be less than or equal to the square root of 9 over 25. Now we do have a bit of a slight problem with this inequality because there's 2 roots to this. So if we square rooted the 9 over 25, we'd actually get a positive and a negative root. It's just like saying square root of 4 can actually be plus or minus 2, because we can have 2 times 2, positive 2 times positive 2 will give us 4, but also negative 2 times negative 2 will give us 4. And this would be the main area where people would make mistakes on this. So if it's the positive root that we're talking about, I can show that by a little plus there, then it's that way around. But if we take the negative root, then the inequality is actually going to go the other way round. So it's going to be the square root of the 1 minus x squared on the left hand side, but this time it would be greater than the negative root of this. This comes from, if we have an inequality, what we do is we if we multiply or divide both sides by a negative number, the inequality changes direction. And this is a similar thing. So because we're taking the negative, the inequality is going to change direction. So next thing we're going to do is this left-hand side simplifies greatly, because if we take the square root of a squared number, so this 1 minus x is squared, then they cancel each other out. And so that would just leave us with 1 minus x. Square and the square root cancel each other. So we can say that's going to be equal to, or less than rather, if we square root this now, square root of 9 is 3, and square root of 25 is 5. So we've got a much simpler inequality to deal with now. I'm just going to rub this out, the one at the bottom, just to give us some space, and I'll come back to that. So, so what we get then is, oops, I need a pen. What we need is to, first of all, let's take the number bit and make it equal to 0. So I'm going to take away the 3/5 from both sides. So what that's going to mean is it's going to disappear here. I'm going to take away 3/5, take away 3/5, like that. So I've got 1 minus 3/5 minus the x is less than 0. We can write the 1 as being 5 over 5. As long as the top and the bottom number are the same, it's going to be equal to 1 there. So take away 3/5 from that, minus the x is less than 0. So if I do that, well, what I've got is take away the top line, so we get 2 over 5 minus x is less than 0. And so what that will give me is that it's going to be to add x onto both sides, and so we've got 2/5 is less than x, and I'd like to write the x on the left hand side, so it just means changing the direction of the inequality. So from that, I've got x is greater than 2/5. So that's part of the inequality done. If we now look at the other inequality, that means the other root where it's a negative root, then what we've got is 1 minus x squared. This time square rooted again, but this time the inequality is this direction, and then that's less than, oh sorry, greater than the negative root of 9 over 25. So the square root and the square again cancel each other out, so that just leaves us with 1 minus x. I don't need to write it in a bracket anymore. And then that's greater than, if I take the square root of the 9, that's 3. And if I take the square root of 25, that's 5. So this time what I'm going to do is add 3 over 5 to both sides. So I've got 1 plus 3 over 5 minus the x greater than 0 now, because if I add 3 over 5 to negative 3 over 5, they cancel each other out. Using the same approach as before, the 1 is 5 over 5 plus 3/5. Take away the x greater than 0. That means we've got 5 over 5 plus 3 over 5 is 8 over 5 minus the x greater than 0. And so this time, if I add x to both sides, so plus x and plus x there, then what that's going to mean is I've got 8 over 5 is greater than x. So these are our two inequalities, and they are our solutions. So x is going to be less than 8 over 5 and greater than 2 over 5. So what we could do is we could leave these answers in these forms, so two separate inequalities, but actually we could write them much neater in one. And what I'm going to do is I'm just going to clear this board off a little bit, just to make a bit of space to explain what I'm saying. So what we got was the two inequalities. X was greater than 2/5, and also x was less than 8/5. And that would be fine to leave the answer in that format, but we can write it much nicer, just as one line inequality. If we can see that the smallest number here is the 2/5, so we could say that 2/5 is on this end, and x actually must lie between these two numbers. Since it's greater than 2/5, we can actually just change the order as long as we make it mean the same thing. So we can say, well, if x is greater than 2/5, that means 2/5 is less than x. We're just changing the order of the inequality, but we can change the direction and it means the same thing. And then we can say, well, x is also less than 8/5, so we can write it like that, just in one line. And that's it. The question's completed. So again, I hope that's been helpful to you. If it has, please like our video and subscribe to our channel by clicking the button at the bottom. And also visit our website, bestmathstutors.co.uk. Thanks for watching.